So Alice picks up R sticks. Bob goes first with 4 Q sticks left in total. That's as if the game starts all over again. And now the number of sticks remaining is 4Q, which is divisible, 4 is divisible by 4Q. So the game starts all over again. And by this inductive hypothesis, we have that 4 divides K implies that the other player, whoever's not going first, player 2, the person that doesn't go first. In this case, it's Alice, because Bob goes first with 4Q. Does that make sense to everyone? Yeah? So any more questions about that?
No, I just got confused with the player 1, player 2 stuff.
Yeah. Whose class is everyone else from? Which, how many people are in the class of Shane Bauman? No. How about Anton Mosinov? How about Bruno? How about Ali or Mohammed, whatever? Whose class are you guys in? Judith? Emma Knight. Okay. All of you from Emma? Anyone not from Emma's class or my class? Okay, so it's all Emma's class and my class. Remember I showed you which class got the highest grade average on Mobius Quiz 9? Emma's class. So that's why they're all here. They're getting extra help. You guys got the highest average out of all 22 classes on Mobius Quiz 9. So, pardon me? Pardon me? Who said hello?
Hello.
Oh, hello. Okay. All right. So does anyone else have questions about this?
So 4 inductive hypotheses.
You could put 4 inductive hypotheses if you're going to use them all. You don't need them all. So here we have. This is just the setup. This is what we want to prove, right?
Yeah.
Do we have to prove all 4 of these? You have to prove 2 of them. Can you prove any 2 of them?
You have to prove like either the first and the second. You just can't match like 4 1 and 2.
Yeah, exactly. So some of these are just contrapositives of others. So this is the contrapositive of that. You can't just prove this and this. If this is 1, 2, 3, 4. You can't just prove 1 and 3 because then you're proving the same thing twice. You're proving the contrapositive, and the contrapositive is logically equivalent to the initial implication. So you're just proving the same thing twice. But you do need to prove, because it's an if and only if proof, you have to prove both the implication and the converse. So you have to prove both 1 and 2, or 1 and 4, because 4 is logically equivalent to 2. Or you can prove 3 and 4. You can choose which ones. Different people will have different preferences based on how they understand this problem. I found it difficult to prove 1 and 2. I found it easier to prove 1 and 4 because 4 was written in a way that was easier for me to understand. So then in your inductive hypothesis, well, you can definitely assume that all 4 of these things are true in your inductive hypothesis. And then when you're proving, in this case, we want to prove number 1, and we're using the inductive hypothesis 4 because that's also assumed. We can assume all 4 of these, and then we can use this assumption to prove the inductive step for this one. That's what I did here, right? I took R sticks. I'm trying to prove that if 4 doesn't divide n, player 1 has a winning strategy. If 4 doesn't divide n, then we know that R equals 1, 2, or 3, because any number n can be written as 4q plus R. So R equals 1, 2, or 3. And so it doesn't divide n. Then player 1, what's player 1's winning strategy? The winning strategy is to just pick up R sticks, where R is whatever this remainder is. You pick up R sticks, that still doesn't mean you've won. Now you have, the game starts over with Bob going first, and now you do divide it. 4 does divide it. And now the person other than Bob has the winning strategy. Alice has the winning strategy. So I use this inductive hypothesis to prove this. And that's perfectly okay, because all four of those are valid.
So from my understanding, you're basically saying that as long as we prove hypothesis number 4, we can say that with hypothesis number 1, we can change the game state so that it becomes the same as hypothesis number 4.
Well, you can't just change the games. The game. What did you say? The game state. The
game state by taking R.
The game state. Oh, the game state. The state of the game. Yeah, you can't just change the state of the game for no reason. We're changing the state of the game. Alice's strategy is to change the game state by taking R sticks and making the leftover number of sticks being a multiple of 4. If Alice takes 3 sticks, or if Alice takes R sticks, the number of sticks remaining is a multiple of 4. So that Alice is smart. Alice knows that if I take R sticks, what's left over is a multiple of 4. And if it's a multiple of 4, then the player that's not going next, but the player that goes after the one that goes next is going to win. And in this case, Alice wins because Alice takes the R sticks, changes the state so that the number of sticks remaining is a multiple of 4. Bob has to go next, and Bob doesn't win because the next person, Alice, will win. Does it make sense?
Yeah.
Yeah, good.
So basically use 1 to prove 4, and then use 4 to prove 1 again.
I used 4 to prove 1. I want to prove this. And I used the 4th hypothesis in my proof for 1.
Oh.
Yeah. And then I've only proven 1. Still, I've only proven 1. I haven't proven this. I've used this where the thing is that 4q is less than or equal to k for my induction hypothesis. I assumed that it worked for all k. For all integers up to k. And then if I'm dealing with the case where I have n equals k plus 1, if I take away R sticks, then I have less than or equal to k remaining. If R equals 1, I'm taking away 1 stick, so k plus 1 becomes k. If R equals 2, I'm taking away 2 sticks, so I have k plus 1, n equals k minus 1. Right? So whatever it is, 4q is always going to be less than or equal to k, which means that it's valid to use the induction hypothesis. You guys got it? Yeah.
So it's gonna this proof is gonna involve a lot of writing rather than
Yeah. And it's okay. In the solution manual, it says that it's okay to use a lot of words. It doesn't have to be all symbols. Like in assignment 1, we forced you to convert these English sentences into only symbols because we wanted you to get used to doing that. But we don't expect you to always use just symbols. It's okay to say Alice's strategy is to pick up R sticks. That's okay. You don't have to convert this into symbols. Okay, you don't have to convert all English language into mathematical symbols. Okay, you probably can. Do you know how to convert that to symbols? Who here is good at converting English sentences into symbols? Can you order a pizza with math? You got to use words sometimes, right? Nola?
For using 4, could you say that when you start with 4 sticks and Bob goes first and is that
Okay, you want to prove 4 now. Okay, why is there only 4q sticks? Oh yeah, that's valid. Yeah, because so if I want to prove 4, then in my hypothesis of the implication, 4 divides n. So all n you can't see if I write over there, do you? Can you see if I write over there? Anyone can't see? You can see? All right, okay. So n can always be written as 4q plus r, where q is an integer and r is 0, 1, 2, or 3. So if 4 divides n, if that's the hypothesis, then I must have r equals 0, right? That's the only way that 4 can divide n. It's if r equals 0. Because if r equals 1, 2, or 3, then 4 doesn't divide n. 4 doesn't divide 4q plus 3. It only divides 4Q. Zev? So induction came into play when I already on the board I had that I proved this using this hypothesis. So in which answer? Mhm. Yeah, okay. So first let's just wait until I answer his question. Or did you want to answer his question?
No.
All right, okay, yeah. You have another question?
Yeah, I do.
Is it related to Zeb's question?
Uh,
Okay, let's just wait until I've answered Zeb's question, then I'll take the next questions. Lucas, then Nola. All right, so you're saying induction is still strange to you? Okay. First of all, my only advice is just do a lot of inductive proofs. Just do tons of inductive proofs. Just spend a lot of time on it, because the more practice you've done, if you've done 200 induction proofs by the midterm, then whatever inductive proof they ask you to do, you'll have the practice. You're laughing about that. 200, yeah. During the midterm, you have 7 days to practice. You have the MathSoc exam bank. There's all the midterms from 2012 until now. There's 9 years worth of midterms, fall, winter, summer. You have like dozens of midterms to practice. Each midterm is gonna have 2 or 3 inductive proofs on there. Practice them all. And as you practice more and more and more, you'll get better and better and better, and you'll understand this much better. It's the same with everything else that you've practiced, right? Like at the beginning, when you were doing long division, when you were 5 or 6 years old, you're doing long division, and it's so hard because there's 9 different things you have to remember. Like you have to do that, you have to do this, you have to do. But then once you've done it 200 times, now you can just do it like that, right? You can do that, right? So it's the same with induction. Trust me, I know from experience. I've taken this course, Math 135, a long time ago. I've also I know people that have taken the course and how they progressed, how they got better and better at induction after practicing more and more. So that's my advice if you're finding induction confusing. Then your other question is, where does induction come into play? Well, induction comes into play because I've assumed all of these things are true up to k. For all integers up to k. Then I want to prove that it's true for n equals k plus 1. Okay, if n equals k plus 1 and 4 doesn't divide it, if 4 doesn't divide n where n equals k plus 1, then r must be 1, 2, or 3. When n equals, so I have n equals k plus 1 and n equals 4q plus r, then I think I can put an implication symbol there. So n equals k plus 1, n equals 4q plus r. Then if I have 4q, let's say this implies this entire implication. Okay, so n equals this, these are just, this is just the setup. This is what I know about n. It's equal to k plus 1 and it's equal to 4q plus r. Then this information implies this implication, which is that 4 doesn't divide 4q plus r, means that r equals 1, 2, or 3. Got it? Yeah. So that's induction, right? I've assumed that this is true up to k, and then I'm trying to prove that this is true for n equals k plus 1. And then the induction hypothesis is used when I say that basically after Alice takes 3 sticks, I've started the game all over again where I am divisible by n. So, 4 is divisible by n, right? You understand? Okay, so Lucas?
Yeah, so first of all, we've proven number 1, right? And now we need to go on to prove number 4. We don't need to do the base cases again, right?
So it depends on whether or not you proved. So first of all, if you've proven 1, you don't have to prove 4. You could also prove 2.
Right, but I prefer to prove.
You prefer to prove 4. You do have, in your base cases, you have to prove both 1 and 4, or 1 and 2. So your base cases this is an if and only if proof. That means not just the inductive step has to have both directions proven. You have to also prove the base cases both ways. So the thing that you want to prove is that this is true and this is true. So in your base case, you have to show that this is true and this is true.
For
You do have to do the base case in both directions.
4 and between 1 and 4, right?
If your base cases are from n equals 1 to 4, then yes, yeah, you have to prove that both 1 is true and 4 is true, or 1 is true and 2 is true, or 3 is true and 4 is true.
And then also for so like you see what you wrote at the bottom there, where like 4 divisible by n means r has to be 0.
Yeah.
So I know you can't take 0 sticks. So like how would I like write that after, right? So I would say like, I guess Bob can't take 0 sticks, right? And then what would my next step be like after that? How do I kind of show it's not divisible?
So n equals 4q plus r,
Yeah.
where q is an integer and r is in the set 0, 1, 2, 3. Now, we want to use this hypothesis, or we want to prove this.
Yeah.
So in our assumption, in our hypothesis, this is, I shouldn't have said hypothesis before. I'm talking about this statement, I guess, or this sentence. So 4 divides n. That is the hypothesis of this implication.
Yeah.
Right? So in order for the hypothesis of the implication to be true, we need r equals 0.
Yeah.
If the hypothesis of the implication is false, then what do we know? Emma's class? If the hypothesis of the implication is false, what do we know about the conclusion or the implication? The implication is true. So you're not proving anything in that. You
Right.
it's just vacuous. You've proven nothing.
Yeah.
So if 4 divides n, you want to prove that 4 divides n implies that, then 4 divides n, it also implies that r equals 0. It's the only way that 4q plus r can be divisible, can be a multiple of 4, right? So we have r equals 0. Okay, and now the question is, we have, so 4 divides n. You don't need to use this, but I'm just basically saying n equals 4q plus r. If 4 divides n, the only way that can work is if r equals 0. So that means n equals 4q. Can you still see that at the back? Yeah. So n equals 4q because r equals 0, right? So that means 4 divides 4q. So that's all I'm saying about the hypothesis here. And then the fact that you're divisible by 4 means that by your inductive assumption, if you're divisible by 4, then player 2 has a winning strategy. So that's the r equals 0 it's not about picking up sticks. The r equals 0 just means I'm just using that to prove that n is the multiple of 4. If r equals 0, then 4q is a multiple of 4.
Yeah. So I want to show since you can't take 0 sticks, the next step it's going to be not divisible. Can I show that in some way, or can I say?
Oh.
You know what I'm saying?
Okay, so you can't. So, but I don't. Why can't they take? Why are you talking about 0 sticks? I'm just saying that r equals 0. So yeah, I think you might be getting confused because in the first, when we were proving 1, Alice's strategy was to pick up r sticks, where r was the remainder, right?
Yeah.
That's done now. We've proven 1. Now you're trying to prove 4.
Yeah.
So you're not using the same strategy as before. We're in a different case now. Alice's strategy might not be the exact same. Now 4 is divisible by n. Alice might not do the same thing as what Alice did before. Alice is not going to pick up 0 sticks. It's a completely different game now. Because in fact, Alice doesn't have a winning strategy here. It's Bob that has the winning strategy.
Yes, that's what I was kind of
So,
trying to
yeah,
prove.
yeah.
Since you can't pick because the next step is going to be not divisible. After Alice takes sticks, then after that it's not going to be divisible by 4. And I don't know how to say that. Right.
Yeah. I think you have to think about this. I think you need at least one evening because I talked a little bit about this in class, and now it's been 1 hour since that class, or 2.5 hours since that class, I think you might have to go home and try to do this. You already know how to prove this using this inductive hypothesis. Now you're asking me how to prove this. And I don't know if you've had enough time to think about it, because you're asking me about Alice picking up 0 sticks, but that has nothing to do with this proof. So I'm just, and I don't want to not answer your question, but at the same time, there's so many other people that want help, right? So yeah, think about it tonight. And then, you know, if there's any instructor that has office hours on Tuesdays, does anyone have office hours on Tuesdays? Yeah, okay, then go to their office hours on Tuesdays. Hopefully it will not be during one of your classes. Nola had a question?
So when you're doing one, you were saying that 4 divides 4q and 4q is less than or equal to k. Would the 4q, would it be 4q plus r is less than or equal to k for the other one? Because 4 would be minus r.
For which one?
For number for 4. Like if after player 1 takes their turn when there's 4q sticks, you have 4q minus r sticks. Would you say that 4q minus r is less than k?
4q minus r probably will be less than k, right? Because you're assuming that it's true all the way up to k. And then so when you're doing your induction, n equals k plus 1, right? And so you've assumed it's true up to k. So you've got all your answers. Did you have any other questions? Oh yeah, okay, yeah, sorry about that. Okay, so you're doing for Emma's class, to what extent does Emma help you with these assignments?
Yes.
Pardon me?
Yes.
Well, yes, to what extent?
No, not at all.
Not at all. Okay, so why do you say yes? Okay, so Emma's not helping you at all with the assignment? Okay.
Office always once a week on 1 hour.
1 hour. That's because she's only teaching one class. So I have 2 hours because I'm teaching 2 classes. So Emma's not helping with the assignments at all?
You can ask her like one-on-one.
Yeah, and then if you ask her one-on-one, what does she got to do? She gives you the answer?
I don't ask. We haven't.
Oh, okay. But anyone else? I should probably not give too much, because if the other instructors are not giving too much, then
Oh, she tells us everything.
let me finish Nola's question first, okay? So, all right, so we want to do the induction. So based on that, I'm not going to be giving you the whole answer for you. You have to do some of it on your own. I've already done a lot of it already. But we want to now prove, so with induction, we're assuming that this is true for all m such that m is between 1 and k, and m and k are natural numbers, and k is greater than or equal to the last base case, right? You got this? And then we assume that 4 divides n implies that is true. So let's call this p of n. You can, in your notes, you can write it down, whatever you had it in your notes before. So we assume that p of k is true. That's your inductive hypothesis. And then you want to consider p of k plus 1. Okay, so now you have that n equals k plus 1. And n also equals 4q plus r. And you want to prove that if 4 divides n, a bunch of things happen. So using that, if 4 divides n, what do you know? Yeah, and what do you know about n? So n equals 4q plus r, and 4 divides it. R equals 0. All right, so r equals 0. So your strategy is not going to be the same as last time. That's maybe Lucas's question. What are you going to do next? Your strategy is not going to be Alice picks up r sticks, because r equals 0. In this case, where 4 divides n, r equals 0. So your strategy will not be pick up r sticks. Or maybe it will be pick up 0. Is Alice allowed to pick up 0 sticks? No, she's not, right? She has to pick up 1, 2, or 3. So your strategy will not be Alice picks up R sticks. That's my answer to the question. I'm not going to go too much more. Does that answer your question? She's not picking up R sticks. She's going to pick up some different number of sticks now. For this case, I've already given you the proof for 1. You've got to do at least a bit of the assignment by yourself. Try to prove 4 by yourself. And I'm just telling you the strategy will not be pick up R sticks, because in case 4, R equals 0. So you might be picking up some other type of sticks. Let's get your question.
Okay, so I just want to like double check the thought process behind this problem, because I think I have like a working rough draft of it, and I did it by solving by proving 4 divides number 4 first, and then I used number 4 to prove number 1. Is that okay, or do I have to like do it?
So you proved 1, but you proved 4 by induction. Yeah, and then you proved.
I used 4 to prove 1. So instead of using 4 to prove 1 first, I proved 4 first.
I haven't seen your whole proof, but, and pardon me if I'm wrong about this, but it sounds like there might be some problem, because you've proven 4 using induction, and then you're using 4 to prove 1. That doesn't look right, because when you're proving if and only if proofs, you're proving both. You have to prove the if and the only if separately. That means you're not assuming this. I mean, you might be able to use it because you've already proven this, and you can use anything that you've already proven. It might be like mathematically, I don't see anything wrong, but in this problem, I don't think, because I know that there's at least 2 solutions in the solution manual for the assignment where they did not do that, where they just proved this independently and they proved this independently. In fact, I just proved number 1 without having proven 4. I've never proven 4. I've assumed that 4 was true up to k, but I haven't assumed that this is true for all k. I've only proven that this is true up to k. Up to some integer k, not for all integers k, but up to some integer k. So I have not used this being true for all k in order to prove 1. You don't have to do that. And if you did do that, it might be right, but there's a good chance that it might be missing something. All right, so who else had their hand up? Vihang had a question. Yeah.
Can I assume that R of n pi is irrational with everything?
Can you assume that what is irrational? Cotangent of n pi, where n is an integer. Can you assume that that is irrational? Why? Why would cotangent of n pi be not irrational? Well, hold on. So let me hear the question. So why would cotangent of n pi be irrational?
Because sine of n pi is irrational when n is an integer.
So why don't you use then why do you have to assume it? Why don't you say that? If you know the proof of why this is irrational, why don't you say that in your assignment? Okay, so then can you assume that sine of n pi is irrational? Why? I don't know. Why? Is that even true? I don't know. N pi. I don't know. It isn't. If n is 0, then sine of 0 is 0. So that's not. This is always equal to 0. Yeah, I think you can't just assume it. You can say that that's true. You can say that sine of n pi is 0. Yeah. I think you can say that sine of n pi is 0. Why does that mean that this is irrational? No, if you're talking about it's not cos over sine if the denominator is 0. I don't think. Someone asked on Piazza about that, right? If you're starting to convert cotangent to cotangent of x into what is it, cos over sine or something? Cos of x over sine of x. If you're starting to do that and considering the case where that's 0, I don't think that's a good thing to do. Someone asked about that on Piazza, and it was recommended not to do that. Let me look at the solution for that. As far as I see, they never assumed that cotangent of x equals cos of x over sine of x, and that this is irrational because of something to do with this being 0. They never used the denominator of this being 0 to prove anything. Yeah.
Say the opposite of a rational number is an irrational number.
I don't know. All the rational numbers, natural numbers, all those things, they're defined in the book, right? How do they define an irrational number? Do they not define it? They just define rational? You've not read the book?
I didn't look into irrational definition.
Okay, so let's see how they define, who knows what page it's going to be. It's going to be early, right? It's one of the first things they teach us. Okay, they define integers, rational numbers, and real numbers. They never really defined irrational numbers, did they?
I think they did.
Where did they define irrational?
I don't remember, but I remember you just said it can't be written as form A over B. I think that was what they said about it.
Yeah, so that's why you have.
Like irrational.
That's why you need a set of real numbers with the ones that are not.
Yeah, so it's real. Yeah, it's real numbers that are not rational. Yeah.
I thought rational numbers were a subset of real numbers.
Yeah, so real numbers that are not rational are irrational, right? Yeah, it never defines irrational numbers in here, it looks like. Maybe if someone has the PDF, you can search Control F, where they actually, because they defined integers, rational numbers, and real numbers, but they never defined irrational. That should actually be in the course notes. I'm going to tell them to add that for next year. So yeah, my understanding is that irrational numbers are real numbers that are not rational.
So one's in the other.
Pardon me?
If they're rational, then you should go irrational.
Well, when you're talking about negation, you're talking about sentences, right? So,
The opposite.
okay, is it the opposite? You can think of it that way. You can think of it that way, yeah. It's not defined that way in the book, unfortunately. I'm going to have to tell them about that. But that wasn't too big of a problem. Like, why are you asking me that? Yeah, for 1B, you have to prove that it's irrational. But what they did do in the book is they proved that square root of 2 is not rational. So they assumed that it is rational, which means P over Q, where Q isn't 0, and P and Q are integers. And then they came up with a contradiction. So this cannot be true while the contradictory statement is true. So then this ends up not being. Yeah.
Yeah, so like from that assumption, we're assuming like if it's not rational, it's not rational.
Yeah, yeah, yeah. If it's a real number that's not rational, because complex numbers, I wouldn't call complex numbers irrational. So they're not rational, but they're also not irrational. I think if it's a complex number, it's a completely different game. If it's a real number that is not rational, I would call it irrational. So yeah, you can do the same proof. You can start the same way that the course notes started to prove that square root of 2 is irrational. Yeah, any other questions? Yeah.
So just want to go back to 4 real quick. So if we try to prove 1, translate the inductive hypothesis as 4. But if we do 4, can we also do the vice versa?
Yes, your inductive hypothesis can contain all 4 of those things if you wanted to, but I would warn you not to put more in your inductive hypothesis than you need. So you only need 2 of these, right? You only need to prove 2 of these. If your proof of 2 of if you want to prove 1 and 4, for example, and you only need the inductive hypotheses for 1, 3, and 4 in order to do that, then I would not put 2 in your inductive hypothesis just because it's making it too much clutter. Just put what you need.
1, 3, and 4.
No, if you needed 1, 3, and 4, if you needed the inductive hypotheses for 1, 3, and 4 in order to prove the induction conclusion for 1 and 4, then I wouldn't talk about 2 in your inductive hypothesis because it's just becoming too many words. And then the graders are going to say, why are you telling me about this and then not using it?
So this is have to prove by induction.
Yeah, you have to prove by induction.
So we have 2 different cases of induction.
Yeah.
2 things.
Yeah, you want to prove this by induction and this by induction, or this by induction and this by induction, or this by induction and this by induction. Any 2 of these that are completely independent of each other, you have to prove by induction. Both directions by induction.
We just like set it up. I just have base cases and then separate them later on. Or I
Sure.
have to
Yeah.
do base cases for each one of them separately.
The base cases need to be proven for what, if you want to prove this and this, you have to do the base cases for that and the base cases for that.
All right.
Yeah, you have to prove the if and the only if. Nola?
The question 2 in the
Next.
textbook, when they're proving, they like set 2 things equal to each other and then solve to the bottom where they're equal. And then so it says like since they're the same, the only value that works is that value. But for this one, it doesn't like go down to the bottom equally. So would you suggest using induction instead too?
I don't suggest induction for question 2. Okay, it's maybe the only one. Well, question 1 is induction. Question 3 is induction. Question 4 is induction. Question 5 is induction. So question 2 is the only one not to use induction. Do what the textbook did, where they found 2 different values of m that work, and then showed that both of those m values have to be equal due to some reasons. So there's some reason why the 2 different m values are the same. Then first prove that m exists such that m squared equals 8m minus 1 or whatever it is. And then show that any other m that satisfies that equation is going to have a difference. Is this a question related to that one? Yeah. You find an m such that it satisfies that equation. So it was an example of m, yeah. And you have to show that it's an integer, not just any real number, but it has to be an integer m.
So it's asking for like an m that works for all of them. Well, like there's for every like let's say k, there exists an m that works. Do you have to do one for every, like if that's possible?
I don't remember the question. It was saying that there exists an integer m such that n squared equals 8m minus 1. Okay, so if you can find an expression for an integer, when I say you're finding an integer m, that doesn't mean you're finding m equals 2 or m equals 5. It might be like m might be k cubed minus 1. I don't know. Okay, where k is an integer. So if you find an expression for m, meaning m equals, I'm not telling you the answer here, but let's say it was k cubed minus 1. If you can prove that k cubed minus 1 is an integer, then you've shown, and that when you plug k cubed minus 1 into here, m squared equals 8 times k cubed minus 1 minus 1, then you've found it an integer m. You've proven that m is an integer and that m satisfies this equation, then you've proven that such an m exists. Then if you find that another m, you assume that there's another m, m2, which equals something else, and you plug it into there and you find that it ends up also being k cubed minus 1, then you've proven that it's unique.
So the first step is basically proving the universal statement, right?
For all n, this is true?
Yes.
Yeah.
All right. All right.
And say like since you're solving an integer system, there's only one error. There's only one error.
No, you'll lose. You'll get 0 if you do. Why would you do that? What?
Did you prove that using the recurrence? Because like it's not quadratic. It's only ever.
That's true. Yeah. So because this is just a number now, so you have y equals mx plus b,
It's only ever one.
and that can only have one solution. But then you're assuming you're not doing a proof. What you're doing is you're assuming.
Just an integer m. Minus
Yeah, wait.
Oh yeah, so that's another thing. So first of all, I wouldn't accept that proof because you're assuming something you learned from a different course, and you're applying it here. That's for some things, like to say that even number plus an even number is also an even number, I think that's fair. But to use this linear systems technology, I mean, in University of Waterloo, that's not taught until Math 136 linear algebra, I guess, right? Or it might be taught in 137 calculus to some extent, or it might be in the polynomial section of this book, and when they start going through the factor theorem. But we haven't covered the factor theorem in the readings for polynomials yet, right? Oh, we have? Okay, so if you can use the factor theorem to prove it, then you might be able to do that. But this proof is so easy without doing that. Why do that? And then the other thing is what he said, which is that for those linear systems, yeah, it's true that if you have a line, it will only cross the x-axis at one point, but how is that an integer? How do you know that's an integer? Yeah, but where have you proven that this is an integer? Where have you proven that m is an integer? I haven't seen your proof. Maybe it works. This proof is simple enough that I would recommend to just redo it without using anything from linear system. Yeah, you're smart, but don't try to be too smart. The graders, if the graders have a solution, they're expecting a certain type of proof. Why don't you just use that? Why don't you just do what they're expecting?
I was just wondering, with the setup for back to question 4, do we need to use those statements to prove, like, let's just say statement 4. If I can prove it without using statements 1, 2, and 3 in my inductive hypothesis, will that still work? If I just
All right. Okay. Yeah. So 1 second. So I'm just going to say that I'm going to take what's your name? Pardon me? Win. I'm going to take his question next because he's had his hand up for a long time. So I'm just going to say, so Vihang, you're after Win. Okay. So you want to know, I want to just prove 4. And I don't want to use the inductive hypothesis of any of these. I just want to use the inductive hypothesis of 4.
Yeah.
Yeah, that's perfectly fine because that's the way we normally do it, right? If you want to prove something, you do an inductive hypothesis for this, and then you use that inductive hypothesis to come up with an inductive conclusion. It's not all the time that you have 2 different things you're proving in the same question.
Okay, great. Thank you.
No problem. Win?
All right, so for question 1,
Yeah.
you give us a tip to show us use 2 cases.
Mhm.
One is when a over pi is an integer, and one when a over pi is not an integer. I already understand like 2 cases in an induction are supposed to make like 2 proofs of induction.
Do what you want. I mean, the fact that you even know that there's 2 cases to do in that question means you've already been given too big of a hint. So do what you feel is best. If I tell you more than that, then I'm telling you too much. Vihang?
Using the question 1.
Yeah.
Using the cases we have k plus 1 alpha over pi is 9.
Okay, so k plus 1 alpha over pi is not an integer.
And k alpha over pi is an integer for 1 of these.
K alpha over pi is an integer.
For 1 of these.
Yeah.
So I guess expand the k plus 1 term, right?
Yeah.
I can write that down as k alpha over pi.
Yeah.
Plus alpha.
Okay.
Sorry, k alpha over pi plus alpha over pi.
Yeah.
And then we know k alpha over pi is an integer.
But alpha over pi is not necessarily an integer.
It's not necessarily an integer, right?
Yeah.
From there, can I say k minus 1 alpha over pi is also not an integer?
Why?
Because k minus 1 alpha over pi is k alpha over pi minus alpha over pi. Since alpha over pi is not an integer. Can I say that?
So you're saying if k plus 1 alpha over pi is not an integer, then k minus 1 alpha over pi is not an integer?
Yeah, if k alpha over pi is an integer.
That's probably true because basically the only way for this to not be an integer is if k alpha over pi is an integer, the only way for this entire thing to not be an integer is if alpha over pi is not an integer. So Why don't you just prove these things? You ask me so many times, like, can I assume this? Can I assume this? Can I assume this? Can I assume this? But you know the proofs of all those things that you want to assume. The proof is just that if this is not an integer and k alpha over pi is an integer, then alpha over pi is not an integer. And now let's take a non-integer and add it to an integer. That's going to also be a non-integer. Yeah. Yeah. Well, you can use anything that you prove using Math 135 concepts. So yeah, you're asking me a lot of times, can I assume this? Can I assume that? But then you know why you want to assume it. You know you want to assume it because you know it's true because you've proven it. Then just prove it on the assignment. Okay? Yeah, so when you figured it out? Yeah. The fact that you have to use, you don't have to use two cases if you don't want to. But I told you that it will be easier if you use two cases. And then that's it. Like, what else can I tell you without giving you the answer or without giving you the exact steps? According to them, Emma's class has not even given them any hints on that assignment. So I can't give him the answer, right? You okay with that?
Yeah.
It looks like the other instructors are not giving. Now they want to pretend that Emma's giving them all the answers, but at the beginning they said Emma's not.
No, she did. Yeah, she said yeah.
No, it's just that we haven't asked.
Yeah.
Yeah. So
She was really nice in the office on it.
Yeah.
She gave away everything.
Yeah.
independent of whatever they say, I can't give you any more than that because I've given you the two cases that you have to prove it for. And then, yeah, you have to prove it by induction. That doesn't necessarily mean you have to prove both of them by induction. You can prove, does it say that the whole thing has to be proven by induction? It doesn't say that you have to use induction. So you can prove case two with induction and case one without, if you want. Case one should be very easy. Case two is the hard one. So for question one. Yeah, your question? So k plus 1 alpha over pi isn't an integer. Isn't that part of the question? It says that without using this? Maybe, I don't know. It might be possible. You want to propose an idea in this tutorial? Yeah?
So like you just prove that like you just like prove that you use induction to say like cotangent is rational number. So like cotangent to alpha.
So cotangent of alpha.
And assume that that's not rational.
Why?
It's given.
Oh, it's given that this is a rational number.
Yes. So cotangent to alpha is also a rational number.
But this is not true if alpha equals 1, right? If alpha equals 1 degree, then this is not true. So where is it given that this is true?
This is for 1A. This is
for 1A. But if alpha equals 1 degree, then
it's rational.
then it's irrational. So why is this? It's part of the assumption of question 1A.
Yeah. It says
If that's rational, then something else.
yes.
Okay. Yeah.
So
So
like,
assume this.
using the trig identity they hinted at, could you prove that cotangent to alpha is also rational?
I don't know, but because that trig identity is like numerator over denominator. It's a lot in there. I don't know what you can prove and what you can't, but I'm trusting you that you have proven that cotangent of 2 alpha is what, rational?
Yeah.
All right, okay. So now you have that cotangent of 2 alpha is rational, and then you want to prove that cotangent of 3 alpha is rational.
It works. It's like the alpha is 2 alpha plus alpha.
Where have you used the fact that k plus 1 alpha over pi is not an integer?
I did it.
So I don't think you've, because that, I think you can only assume this under that assumption, right?
Well, yes, like I mean, like I don't explicitly use that.
Yeah, you don't have to explicitly use it, but when you're assuming that that's true, that's only if this is also true, right? Because this doesn't always work. In fact, if alpha equals 1 degree, it's not rational. Why is it not rational when alpha equals 1 degree? probably because this is not satisfied maybe. So you do need to use this.
Wait, we need to use k plus 1 alpha over pi is
You don't have to explicitly use it. Like you don't have to plug that into something, but that has to be part of your assumption, I think.
Oh, yes. Yeah, because if you try that would be it's that.
Yeah, and the denominator of that hint that they gave you can't be 0. So that has something to do with this as well. Okay, who's next? Rosado? No? Lucas? Vihan?
When you're 1-8, for me, the 8
All right, that's fine.
Did you say the 8 is harder?
Well, I mean, just because it was harder for the rest of the class doesn't mean it's harder for you. You might have found question 4 to be the easy one and question 2 to be the hard one. Yeah. Okay, so we're getting to around 6 o'clock now. So does anyone else have any more questions? From Emma's class, from my class?
Will this video be available somewhere?
Yeah, that's the whole point of it, so that you didn't have to so that you didn't have to record me.
So what we all like learn or
I'll post it somewhere, so you know how to contact me.
yes. Wait, so your name is
Nike.
Nike.
Yeah.
All right. I can probably set you up on other
On what? Pardon me?
Outlook. I can email you.
Yeah, you can find my email address and send me an email. Yeah.
Yes.
Yeah, and I know you asked that question too. Definitely, some of these, like already I know some people on Friday won't be here because they're going home for the reading week. So they already told me that they need the recording for Friday. So
we just message you.
yeah. Just message me in the MS Teams. Yeah.
Actually, for Friday, do you want me to stream it?
Because I can,
haven't practiced that yet.
because the thing is, like, I can, you have the link to the Zoom meeting. So that means you can put it on Learn or whatever, and then, or I could set up another one if you don't want to make a.
I could do that. Yeah.
And then we can use that.
We could. Let's see. I don't think I want to add too much complication because there's 2 or 3 people. There's one person that came to me saying that she's going home for Thanksgiving, and if I stream it, she won't even be able to see it anyway because she's going to be on a 9-hour bus.
Oh, okay.
So she's not going to be watching the stream. She's going to be watching the recording later.
Yeah, actually, I want to offer in case it would be useful.
Yeah, I appreciate the offer. I think I'd rather not do it because as it is, I'm struggling to start on time because we've got to do this and that.
Oh, it wouldn't be anything extra for you. It would literally just be the same thing, and then they join.
Yeah. Okay. Yeah.
So it's basically, I would take care of pretty much everything except posting the link because I can't do that. I physically don't have
So
access.
I would have to give the students the link to the live stream.
Yeah,
Yeah. And I don't know if
and other than that, you wouldn't have to do
extra
anything.
stuff. Yeah.
Yeah, but what do you know?
Yeah. I don't want people missing the class because
That's why I was saying, like, maybe I can set up like a specific meeting that's only that one time if you want to avoid that.
we could. Yeah.
There's any number of things, but it's
I
like,
think it's not necessary because
Okay.
the only person that would take advantage of it so far that I know of is someone that's not going to be able to watch the live stream.
okay, that's fair.
Okay, so you guys asked a lot of questions. Yeah. You guys are good?
Thank you.
You guys are good on the assignment? Yeah. Yeah, you can prove 1 independently and 4 independently without using any of the other hypotheses. Yeah. You guys are good? You didn't ask so many questions. You're okay? Yeah. Okay, so yeah, let me look at this stuff. You guys are okay?
Yeah.
I know we might have carried over.
Oh, great.
One is yeah, this is one thing. Yeah, that's what
I'm not sure, but
Yeah, so I wrote like a line here that we can break every case of n equals 4 plus r where 2 is the
Okay,
r
I'll take a look.
Yeah, into a question.
Is it okay if I just assume this? Like this is all
You're gonna have to write it a lot neater than that because
Yeah.
that's not math, right? That's just You're taking sets and you're multiplying.
Yeah, that's
So-
rough work. I can write it as
You
b over
can't
a
just
or
do
whatever.
integer times integer
Yeah, I know.
minus 1 over
No, that's the
integer squared.
that's
plus two.
Yeah.
Maybe, but that's for 1A or 1B?
1A.
Maybe.
Well, I can show you like the fraction form.
Yeah, I would rather you put it in this type of form and then actually do, because here you have actual variables, you can actually multiply these together and stuff.
Yeah, yeah. Okay.
You can't do that for here.
Yeah, I
If you
know.
put that on the
This is-
assignment, you're gonna lose marks.
Alright.
Yeah, you're okay? Yeah. Sometimes, like, you know, I've given a lot of information here, you've got to go home and look at it. And then if you're still confused, you can go to someone's Tuesday office hours. Okay, so you guys are in what program? Math and business or what?
Yeah.
Just CS. Everyone? You guys are also in CS? Your whole class is CS.
Plus, yeah.
That's why their average was higher. Oh. Emma's class has the highest average for MQ9, for Mobius Quiz 9. But, yeah. No, actually, it's been that way for most of the quizzes and the assignments. Like, yeah, you guys are just way ahead of the rest of the 22 sections. It's probably because you're all because to get into CS, it's harder than to just get into regular math. Yeah, yeah. Okay, please do so that my class gets a higher average on the midterm.
Careful, that's what that's what
Don't do the
ECE
last
tried.
3 questions. Don't do the last 3 questions.
Careful, ECE tried that and they got screwed by it.
They tried to not do the last 3 questions.
They tried to purposely work together to bomb the midterm in order to get curved higher. And everyone knows about it. It was so funny. I think it was like 121 or something.
Okay.
We all laughed at them.
Yeah.
I think that's everything.
Okay,
So
you
should I
guys
just
have more questions? Okay, I'm just gonna look at this guy's proof. We proved the result by strong induction on N, where P of N is the open substance. Okay. Okay, one thing already, you say we proved this result. What are you proving? We proved this result.
According to the book,
Yeah, but maybe, yeah, for the assignment, maybe you should say what this result is. We prove what? What are you proving? Yeah, we don't need this, right?
Nope.
You can use all that stuff, yeah. So,
I'm still recording. Do you want me to stop?
sure, yeah.
Okay.